Okay, so we want to check whether a tree is symmetric. Today we're looking at a binary tree, so whether if we have a mirror down the middle, whether um, we see the values match up. So yeah. So here's an example of where we should output true, because if we put a mirror down here, 4 and 4, 3 and 3, 2 and 2, and 1 is itself. And then here we have 1, which is at the root. We have 2 and 2, okay, but 3, well, we expect a 3 here. Since it's not here, then it's invalid. Of course, over here we because it's nil, we also expect a nil here, but that isn't the case, so this is a valid case as well, and yeah, we return false. So let's look at the recursive approach first. So yeah, okay, so let's think about how we want to approach this problem. So with recursion, what you want to think about usually is going all the way down, so like the depth, right? It's like, what problem do you want to solve? One is, over here, okay? So yeah, I think it would be helpful to have a helper method. Just to keep things a bit more clean, and we can modify the parameters as needed as well, right? Yeah. So let's pass in a left hand side node and a right hand side node. Right. So once we get here, what I want to do is to basically know whether, like, this guy over here is equal to me. And when I'm here, I want to know whether this guy over here, right, is equal, this guy over here is equal to me. So come to think about it, I think we might want to do a check not once we get all the way down here, because it seems like it would be much more difficult, much more cumbersome. But we want to basically pass in values as we traverse down the nodes, the tree. Okay. So I think what I want to do is, so first I check if there's a root or not. I mean, if there isn't a root, we also want to return true, because I think nil is still viable as a symmetric tree. So basically, I think I want to pass in the left and the right, to begin. Right. And then I would just recursively call on to self and work on the logic from there on. Right. Okay. So let's think about some scenarios where there are base case. So the first thing that we might want to check is whether both of these values are nil, right? So if both are nil, then we can return true. Okay. And if one of the value is not nil, we want to return false, right? So just think about it. If we have a 2 here, but then we have like a nil here, then I want to return false. So otherwise we have 2 valid, or not and. Otherwise we have 2 valid nodes right here, and we want to check the value, making sure that they match up. And the val. And let's return false. Okay. And in addition to this, I want to make sure that the left and the right node continues continue this logic, and we're gonna continue to check. Okay. Child. Okay, for the left child, we want to check with the side node dot left. Then for the right node, we want to check and side node dot right. Okay, shift the right and left. We want that these two to be true as well. And right child. Okay, so let's give this a run. Okay, funk. Okay, we output false, but when it should have been true. Let's see what's going on here. Let's look at debugging this. 2, 1. Okay. If it's a no, it's an incorrect. Okay, so easier if we just print the values here. Okay. Actually, here, yeah, see what I was thinking about is if one of them is nil and the other isn't nil, then I want to return something. Return false. So that was the idea, but this logic does not apply. So let's think about this again. So yeah, so if both of them are equals to nil, then of course we return true. Now if one of them, right, is nil, these. If one of them is new. Okay. Okay, I think this would do. Okay. Okay. Let's give the submission. Okay, so this one is wrong. Expected false, but then we got true. So let's see what's going on here. Okay, so let's go through this. Okay, so 1, right, we have 2 and 3. Okay, so passing the left is 2, pass the right with is 3. Then you go for this. Both of them no. Okay, I mean if you go over the way over here, yeah, then you'll be like, okay, yeah, it is. But we're still here. So I want to check is no. So 3. And this doesn't apply. If either one is no, of course doesn't apply again. And now we check for this. Make sure that the values equate. Just make sure that this isn't the case. Oh, it returns true. I see. Okay. So over here, I'm passing the left. Right. Wait, but it should be false. Okay, right hand side. Here's the bug. Okay, submit it. Okay, so there you have it. So this is supposedly an easy problem, but as you can see, if you miss out a detail over here, over there, you copy and paste, some code here and there is easy to just get mixed up. And yeah, I hope you've seen how I went about solving this problem. Of course, it's not something that I memorized, so you saw me how I went about solving the problem, my thought process, and perhaps most importantly, I think, is the debugging process. So yeah, so that's how you go about solving it using recursion. And of course, another way you could go about solving this problem is to use a queue. So we can give this a try. Why not, right? Sounds like fun. All right, let's do this. Turn true. Okay, create a queue. Okay, so what I want to do, right, in this queue is basically just to add these two child. So we have like a tuple, right? Add these two child, and then we want to basically go through the same validation logic of whether the current two values that we're looking at a viable symmetric child. So that is the idea. Okay. Left dot right. Okay. Alright, so while the queue isn't empty. Okay. I want to check these nodes. Okay. First. Node. Okay. Okay, so we pop it off. Now I want to make sure that well, if I want to just make sure that that there are value in these two, right? So got let else I want to check so we're checking if both of them have values. Now if either value has value, if either node has value, we can return false here. Right? Otherwise, I think we can continue. Now we want to validate that these two values equate. If they does not equate, then we can return false. Okay. Otherwise, we want to append to the queue. We want the left, the right hand side node, right, and right hand side node, the left, and I think this should do it. Let's give this a run. Okay, that. Okay. Alright, so there you have it. You also seen how you could go about solving this problem using the iterative approach. Okay, hope you guys enjoy.